topic is Archimedes principle. Generally, this principle works on the beyond forces, which we have seen in the last lecture, right? So ये आर्किमिडीज का प्रिंसिपल है क्या? तो जनरली वो उस प्लावक बल पे काम करता है बियॉन्ड सी फोर्स, राइट? जो हमने लास्ट लेक्चर में देखा था. द फोर्स विच एक्सर्ट्स इन अपवर्ड डायरेक्शन बाय द फ्लूइड, जो कुछ भी ऐसी चीजें जो बह सकती है, लाइक एयर और वाटर, समथिंग लाइक दैट, अ लिक्विड और अ गैस, राइट? तो ये लिक्विड और गैस अपने अंदर कोई भी चीज अगर आए तो उसपे वो एक फोर्स प्रोड्यूस करती है जो ऑलवेज अपवर्ड डायरेक्शन में होता है, और उसे हम कहते हैं बुयंसी फोर्स. तो ये जो बुयंसी फोर्स है, इसके लिए आर्किमिडीज ने एक प्रिंसिपल दिया है कि ये फोर्स की वैल्यू कितनी होगी हमें कैसे पता चलेगा. तो वो हमें दिया है आर्किमिडीज के प्रिंसिपल में. सो उसके लिए सबसे पहले उन लोगों ने एक एक्टिविटी दिखाई है कि कैसे बुयंसी फोर्स इज वर्क इन अ फ्लूइड, right? So for that you have to take a one stone, right? The shape should be not finite or something like that, okay? You can take any shape of a stone, right? So if we take a stone and if we tie it with a rubber band or a elastic rope. Why the elastic rope? Because when the force is produced on it, that elasticity should be increases, means the rope should be increases in a length, and just because of that we are using the elastic rope back here, right? So we are using an elastic rope like that. So here is the elastic rope, we just tie it with a one unshaped one stone, right? Then this shape is not a finite or something like that. So here it is the stone which is tied by the elastic band, right? Now I have to just put the other end of the take the other end of the rope and just I have to free falling that object. So due to the gravitational force, the length of elasticity will increase. If in case I am just thinking that its length is L, only for assumptions we are just taking the increase in a length is the L, the total length after increasing due to the gravitational force which is applied in a downward direction, which is generally we can say is a weight of that object, because the weight is the gravitational force of that object on that place, right? So we can say that here it is the weight, or due to the gravitational force, this the length of the elasticity is increases, and in case if we assume that the total length of elasticity, when we just freely put the stone, then it becomes L, okay? Now अब हम ऐसा करेंगे कि एक ऐसा वेसल लेंगे जिसमें हम पानी भर सके. बड़ा होना चाहिए जिससे वो टूटे ना, और ग्लास का हो तो बहुत ही अच्छा रहेगा, ओके? तो यहाँ पे हम लोग पानी भरेंगे. We need a fluid. You can take any of the fluid like a kerosene or a petrol or something like that as you want. But generally, if we want to do a practical, the most convenient is water, because we do not need to pay a money for it, a high amount of money, right? So here it is, we are taking a water. Now put this object in this bowl or a vessel, okay? Now, so when we put that object in a water, after that the length of elasticity is increased at here also, right? If we think that the length is the ls, but when we compare both the lengths, always L becomes greater than L dash. What is the reason? As you know that the weight of object never be decreases when you put inside of water or any liquid. If you put yourself in a liquid, then is it possible that your weight will becomes decreases? It's not possible. Weight is always same, because it is only depends on the m and g, where the m is constant and g is only depends on the gravitational force, and for the earth it is always constant, which is 9.8. So this one is constant, this one is constant, and how the weight can be less? So weight doesn't less, it means what is the reason that the length becomes less? Because there is one another force applied in an upward direction. So as the rope increases its length due to the fluid, it just goes some of the upward direction like that. So length becomes less as compared to when we put it in an air. Understand? When we put it in an air, there is a force, buoyancy force is not that present. Right? So the weight, due to only a weight, that object goes in a downward direction. So the length is higher. But at here, the two forces are working. One is in a downward direction, another one is in an upward direction. So if we are thinking that if the weight is 10 Newton, then at least buoyancy force becomes 2 Newton. Then there is only 8 Newton working in a downward direction. While at here, fully 10 Newton is working in a downward direction. And just because of that, this L is more than the L. So you can say that always liquid applies a buoyancy force in an upward direction. And for that, the Archimedes give a principle. What is the principle? Whenever you put an object partially or fully immersed in a water, the total buoyancy force applied on the water is exactly as the weight of the water displaced by that object. Okay, I'll explain it. Like if we are thinking, there is one vessel with a water or any liquid, okay? If we are thinking about the vessel. And there is a water inside of it. Okay? So like that. If I put one object inside of it, one object inside of it, due to its volume, the level of water is displaced by some distance. This always happens, right? जब आप लोग किसी चीज को किसी लिक्विड में डालोगे तो वो लिक्विड का स्तर ऊपर आएगा, उसकी ये जो सरफेस है वो ऊपर आएगी, क्योंकि इसकी वॉल्यूम ने कुछ जगह रोकी है, तो वो जगह इसको कवर करनी होगी, तो वो ऊपर आएगी। तो ये जितना ऊपर आएगा उस पानी का हमें लेना है वेट, and this weight gives the value of buoyancy force. This weight gives us the value of buoyancy force, which is applied by the liquid. So generally, if we take one vessel fully filled with water, and if we put one object inside of it, due to the volume of that object, some of the water comes outside of it. Then you have to take that water and measure a weight, and you can find out the force of buoyancy force. So here it is the principle of Archimedes. Then whenever an object is partially or fully immersed in a water, you can put there a partially also, half of inside and half of outside, right? So due to that also its surface increases, right? So you can say that whenever the object partially or fully immersed in a liquid, the buoyancy force applied by a liquid is the same as the weight of a liquid displaced by that object. उस ऑब्जेक्ट के द्वारा जो भी लिक्विड डिस्प्लेस्ड हुआ है उसकी वेट जितना बुयांसी फोर्स ये लिक्विड इस चीज पे लगाएगा। तो ये है हमारे आर्किमिडीज का प्रिंसिपल। अंडरस्टैंड? There are so many uses of the Archimedes principle. Like generally the Archimedes principle is used in design of ships and the submarines. Right? They are using in a design of ships and submarine. Right? So generally the Archimedes principle is used in the design of ships and a submarine. The second usage, it is used in a lectometer. lactometer. The lactometer is a device which used to find the purity of milk. So sometimes they can ask you a question like that. Which device is used to find the purity of milk? Then it is a lactometer. And that lactometer uses the principle of Archimedes for finding the purity of milk. Like that. The another use is, it is used in a hydrometer. Hydrometer. The hydrometer is a device which can easily find out the density of any object. For finding the density of an object, we are using a hydrometer. And this hydrometer uses the principle of Archimedes. Right? So here it is the three uses of a principle of Archimedes, which can be asked you in your exam for 2 marks. And sometimes the single points can be give you a 1 marks also, because they can be asked you as a MCQ or for a 1 marks, like which instrument is used for finding a purity of milk, and sometimes for finding a density of an object. Then you have to write the real answer or right answer, which is a lactometer or hydrometer according to it. Understand? Now our next topic is relative density. Generally this relative density shows that the object will emerge or the object will float or sink in a water. Understand? Which will give you by the relative density. So our next topic is relative density. Before relative, we are going for the density. What is the density? Then the density is the mass per unit volume is known as density. Mass per unit volume means the density is equal to mass per volume. Understand? So here it is the density equations. That the density is equal to mass per volume. Generally the SI unit of a density is, as the SI unit of mass is kg and the SI unit of volume is meter cube, the SI unit of density is kg per meter cube. Understand? So here it is the density. That how much mass is present in a volume. Like if you are thinking about the two objects, like one rubber ball and one balloon. As you can see that the rubber ball has a higher mass in a smaller volume, while the balloon has a less mass in a higher volume. So the density of rubber ball is higher than the balloon, because the volume is less and the mass is higher, so density is higher. And in a balloon, the volume is more and the mass is less, so the density is less. And just because of that, whenever you put two objects in your hand, you can easily feel the mass of that object more as compared to the other one, due to the less volume and higher mass. And at here, a higher volume, less mass. So this is the density. And according to this density, sometimes the object sink in a water and sometimes they float on a water. If the density is higher than the density of water, they will sink. And if the density is less than the water, then they will float. Then we need to know about the density of water. Then what is the density of water? So the density of water is (1,000 kg per meter cube). If you convert it in a CGS ekam unit, then you can say that it's a 1 gram per centimeter cube. If you take it in a CGS, then it's a 1 gram per centimeter cube. But in a SI, the density of water is 1000 kg per meter cube. Right? Like that, the density of gold is 19,300 kg per meter cube. And the density of silver is 10,800 kg per meter cube. So here it is the density of different objects. Like a water has 1,000, gold has 19,000, the silver has 10,000 kg per meter cube. So here it is some density. And if the density is more than the water, they will sink. If the density is less than the water, then it will float. But the main thing is that we have just discussed about the density. What is about the relative? Relative means we have to compare it with some another density. Like in a motion, we have said that a motion is the relative quantity. What is the reason? Because we are relating with the observer's position. Like that, we have to relate the density with the another one. Then you can say that it's a relative density. Then with which density we should be relating? Then we should be relating with the density of water. So we can say that the density of an object, the ratio of density of an object with density of water is known as relative density. So the relative density of water, relative density of object is equal to object's density divided by the water's density. So whenever we take the relative density, we have to take a water's density as a denominator, right? So the answer can become a more than 1, can become a 1 or a less than 1. If it is more than 1, it means this one is higher than the water. If the denominator is less, then you can say the answer will become more than 1. Then the object sink. If it is less than 1, it means this one is higher than the object's density. So it will float. And this one immersed. Or you can say that it just goes in a center of that water. Understand? So like that. And most important thing is that SI unit of relative density is actually it is unitless. There is no unit of relative density. Because the density, object's density is kg per meter cube. Here it is also kg per meter cube. So both the units are cancelled out and you get no unit of the relative density. So it is a unit less. Understand? So now, there is some questions I given to you. Like an example, which is use this equation. Right? What is the question? Question is that the relative density of a silver is 10.8. The relative density is given to you. Right? So at here, what is the example? Example 10.7. So the relative density of silver, which is 10.8, and the density of water is 10 cube. Density of water is 10 cube. Kg meter raised to minus 3 means kg per meter cube. Then what is the density of silver? The simple equation is that the relative density of silver is equal to density of silver divided by the density of water. The relative density is 10.8. The density of silver we have to find out. And the density of water is 10 raised to 3. Put this 10 raised to 3 on the other side, then it becomes 10, 8 by 10. If I remove the point and into 10 raised to 3 is equal to density of silver. So we can say that the density of silver is equal to 108 by 10. I can write a 10 raised to 3 as 1000 There is a 3 power, so you can put the 3 zeros. These zeros are cancelled out and you get answer 10,800 kg meter raised to minus 3, which is the density of silver. So like that you can find the density of any object with the relative density given to you. Understand? Now, just watch it for some times. Okay, now, then some questions are given to you in an exercise, so I will just solve it. The first one is that every object feels the gravitational force and which is directly proportional to the mass of the object. Then why the heavy object cannot come quick as compared to the light object? As you know that the force, gravitational force, generally depends on the mass of an object. Okay? I'm just removing it from here. Then everybody knows that the equation of the gravitational force is F is equal to G, the capital M, small m divided by d square, where the G is the constant, M is the earth, mass of Earth, and here it is the mass of an object. Understand? So like that, if we think about it, then this F is directly proportional to the M. And if it is then you can say that if the mass is increases, the force is increases. So if we took a two object, one as a heavy object and one as a light object, then the force exerted on heavy object is more as compared to this. So it should become quick as compared to the light object. Understand? Just think about it. If there is a two persons, like one is a sumo wrestler and another one is the popatla. If you apply the same force on both of them, which one quickly come to you? Of course, popatla. But if you want to move both with the same velocity, then you have to apply a more force in the sumo and the less force on the popatla. So they can come at the same rate. The same thing is happening. The object is heavy, so it needs a more power. And the object is light, it needs a less power. So according to it, you can say that the gravitational acceleration produced in both the object is same because gm by r square, in which it does not include the mass of an object. Understand? Just because of that, this gravitational acceleration does not include the m. Because if you want to move this heavy object with a same acceleration as that of one, then it needs a more force, it needs a less force. So, if we are using a more force and at here we are using a less force, after that the acceleration produced in both the objects are same. So they came at the same time on the earth. Understand? Now, second question. The third one was just done by you. Now the fourth one. The earth and the moon attracts each other with a gravitational force. The earth exerts the force on a moon and the moon attracts the force on a earth. Which one is bigger? A earth's force or a moon force? As we say, if there is a two object like that, one is a capital M, another one is a small m, and the force between both of them is this one. Here is the distance. So if the force applied by the earth is this one, then the force applied by the moon is also the same because the equation is same. It includes the gravitational constant which will never be changed. Now the mass of earth, okay? Mass of moon and the distance between both of them. These forces not only exerted by the earth, these forces also exerted by the moon. So both the forces are same. Both the forces are same because we said that according to the universal law of gravitation, that every objects in a universe attract each other, and this force is directly proportional to the mass of the both object and inversely proportional to the square of distance between both of them. Means if there is a two objects, then one object exerts a force on one another, then the another will attract with the same force to the first one, right? So both the forces are same. Then the question number 5 just gives according to it that if the both forces are same, means the moon also attract the earth, then why earth cannot goes towards the moon? As we know that the moon is always move around the earth, right? Never earth goes towards the moon. The force is same. It means if the forces are same, then both should be attract each other. But it's not happening. Actually, this type of thing is happening. It doesn't attract. The earth is not attracted towards the moon, and the moon is not attracted towards the earth. The reason is that the mass of an earth. Forces are same. As I said, if one is the sumo-rashtra, one is the Popetan. If Popetan wants to attract the sumo-rashtra, it needs some more force as compared to the sumo-rashtra's force towards the Popetan. So the forces are same, but the mass of earth is higher than the moon, and moon has a mass which is negligible according to the earth. So the acceleration produced in the earth is also negligible, that the earth cannot move towards the moon because of the mass of the earth. That force is not appropriate to attract. It is not enough to attract the earth. Understand? So both the forces are same, but as the king is the earth, it attracts the moon because earth has a higher mass and the moon has a less mass. Now, some other questions, like the question number 6, we have done it. Now the question number 7, that you know that, right? We have give the 4 examples, and I have also give questions according to it. Now the question number 8, what is the acceleration of free falling object, which is the 9.8 meter per second square, which we have used in many sums. Now, what we call the gravitational force between the earth and any object, which is weight. Generally we call a weight of an object on the earth, which is the gravitational force applied by the earth. So it is a weight. Now the question number 10, that the Amit buy some gold for his friend on a poles, right? And then he give it to his friend on the equator. Then that friend will be satisfied by the weight of that gold. If not, then why? As you know that the earth is not a fully circle, right? So just for understanding, I am just drawing a earth like that, like an oval shape. Actually not it is that much oval, but for just an understanding. Okay? If you are thinking about it, and the weight is generally the gravitational force. Okay? Which is generally the gravitational force. And as the gravitational force, W is equal to mg. But exactly that mg, where the g is the g capital M by r square. Okay? And we are just multiply the m with it. And as you see it here, there is a r included in it. And for earth on a poles, that r is less. And as the r less, the weight is higher. And then you give it at the equator where the r is higher. And as the r is higher, the weight becomes less. So when he bought a gold on a poles during the time, its weight is higher. And when he give it to his friend on the equator during that time, that the weight becomes less. And just because of that, his friend never is satisfied with the weight of that gold. Because Amit always wants to, Amit said that the gold is that much weight, right? But on the equator, its weight becomes less due to the radius of an earth, which is increases at the equator as compared to the pole. It is just for your understanding. I am giving a figure like that, Earth's figure. It is not that much oil. Understand? Now, The question number 11. A one sheet of paper and the one another which is made by that sheet, which is a ball. If you put both at some height, then why the paper will come slowly as compared to the ball? The simple thing is that the sheet of paper is like that and the ball is like that. Okay? So if the force is applied on it, okay? So this one is the force applied on it. And if we are thinking about the pressure is F by A. So the pressure produced on that object in a downward direction, as the gravitational force is there, the pressure is in a downward direction, which is less as due to the area, because it has a higher area. While at here the area becomes less, so the mass is same. The mass is not changed because it is made by this paper. So mass is same, but the volume decreases, and as the volume decreases, the pressure produced on it is increases, and as it is increases, it comes quickly as compared to the sheet of paper. Due to this reason, the sheet of paper comes less than the ball. Understand? So here it is some of the questions related to it. Now question number 12, you can do it by yourself because it's of a sum of a weight in which the mass is given to you, and you have to find out the weight. Like it is an example 10.4 and 10.5, in which first of all you have to find out the weight on earth by 10.4, and then you have to convert it into weight on mass according to the 10.5. Then you have to do this question number 12 by your own self. The question number 13, 14 and 15 is also done by you, because this is also the questions like example 10.2, 10.3, something like that, right? Just you have to find out what is the U, what is the V and something like that, then you can easily find out it. So the question number 12, 13, 14 and 15 are the homework for you. So we are just finishing our lecture today, and another one, that the last topic of this chapter or the another remaining exercise will be seen in the next lecture.